Good morning. This is your Stat Sensei, Mr. Spensei, and this is an exit ticket on central limit theorem. By the way, this will tie directly to the warm-up that we did. It's essentially the same problem, except now we're dealing with the distribution of the sample means versus individual values. So look at this. IQ scores are normally known to be normally distributed with a mean of 100. All right, so let's make a note of that, mean of 100 and a standard deviation of 15. A random sample of 100. Ooh, we have a sample of 100. Let's note that down. So our N is 100. Um, IQ scores was taken. Use the graph below to apply the central limit theorem and the empirical rule to graph the scenario. Be certain to label the z-scores and the standard deviation of the sampling distribution. We'll come back to that. Let's start with the z-scores because that's the easy part. All z-scores are centered on 0, 1, 2, 3, positive infinity. That's our upper z, our positive z-scores. Our negative z-scores are -1, -2, -3, and that's negative infinity. And that's our z-scores for the lower half. Well, they're going to ask us for the mean of the sampling distribution, and the mean of the sampling distribution, the mean of the mean is the mean. So in this case, the mean of X bar, the mean of the sampling distribution is 100. That part's easy. So this is going to be 100, not a problem there. But then they're going to ask us for the standard deviation of the sample means, which the standard deviation of X bar is the standard deviation of the population divided by the square root of n, which in this case is 15 divided by the square root of 100, and that equals 1.5. So the distance in between each one of these is 1.5. And I highly recommend that you go back to the previous video and make a comparison between the two. Well, if this is 100, this means this is 101.5 because I just added to it. This makes this 103, and this makes this 104.5. Taking away 1.5, I end up at 98.5. Take away another 1.5, and I end up at 97.0. And taking away another 1.5, I end up at 95.5. All right. We also need to put our labels in for our empirical rule. This is 68%. This is 95%. And this is 99.7%. What is the upper and lower bounds for plus or minus one standard deviation? Oh, well, the upper and lower bounds are 98.5 and 101.5. What is the upper and lower bounds for plus or minus 2? Well, our 95% is 97.0 to 103. What is the upper and lower bounds for plus or minus 3? Well, that's going to be 95.5 all the way to 104.5. Then the next thing, what percent of the sample means of 100 will have a mean greater than 100? Oh, well, that's right in the center. So 50% will be greater than 100. So 0.50 or 50%, either way you'd like to write it. Using your calculator, answer the following. How likely is it that a randomly selected group of 100 would have an IQ greater than 120? Now, keeping in mind, we did this on our warm up and we ended up with one value. So let's go ahead and talk about this. First off, I'm going to make my probability statement. We want the probability that X is greater than 120. We know our sample size, we know our standard deviation. So that's what we have right here. And we can do this one of a couple ways. For this time, I'm just going to use a norm CDF. So norm CDF in this case, I better draw a picture of this. Our picture is going to look like this. We have a mean of 100. We have a standard deviation of 120. And we're going to shade all the way to positive infinity. All right. And we're looking for this area right here. So norm CDF, when we do that, the calculator is going to ask for the lower bound, which is 120. It's going to ask for our upper bound, which is positive infinity. It's going to ask for a mean. Our mean is 100. And our standard deviation, we have to be careful. We're not using 15. We're using 1.5. All right. So this is my lower. This is my upper. This is my mean. This is my standard deviation. And then I'm going to come back and do this slightly differently. Second vars, normal, CDF, lower bound, 120, upper bound, 9 raised to the 99th, mean of 100, standard deviation is 1.5, not the 15. And it's like, oh my gosh, that's really, really small. That's approximately 40 zeros. So that's approximately 0.000. So approximately zero. Not going to happen. Almost impossible. So it's approximately zero. All right, I wanted to show you one other place to go because this is going to be really important. Stat, test. I could go to z-test and watch what happens. Press stats. Mean, 100. Standard deviation of the population, 15. Our sample average, 120. Our sample size, 100. With our probability statement, we shaded to the right, so we want to make sure that we have the same arrow. And press calculate, and there we get the same value. All right. So I think ultimately it's easier to switch to z-test at this point, but I use the norm CDF because that's what we've been working with. Next thing, would it be okay to use the distribution of means if the sample size had been 10 instead of 100? And the answer is yes, it would be okay because the population is normal. All right. Now, if the population hadn't been normal, or if we hadn't known, we would have needed to have a sample size of 30 or more. But since they told us up ahead at the very beginning, they said the population is normal, it would be okay to do so. So the underlying population is not normal, or we don't know. We need a sample size of 30. If it is normal, we can use a very small sample size. All righty. I appreciate you watching and hope to see you on the next one. Thank you.